All right, part C. When is the population this 9,000 and this 6,000? So this is a when question, so I need to find t, or I need to find my x values. These are my y values. Oops, my y values. So if I am given y values and I want to find the x values, this involves a little bit more calculator work. So for the first one, I want to also graph y equals 9,000. And what I'm going to do then is go back to y equals, make a second equation with y equals 9,000, graph it, and now I can see two places where that actually happens. So I'm going to calculate what those intersections are. So again, we're going to go to second, then calc, scroll down to intersect. It's going to ask for the first curve, and that's just a fancy way of saying what's the first graph that you want to find an intersection for. And it's going to be this blue sinusoid, and then the second curve is going to be my horizontal line. I hit enter, and now I have to kind of tell the calculator which intersection I'm looking for. I'm looking for this one, so I'm going to scroll over here and hit enter. So that is going to be my first intersection. So that's at x equals 1.33. So this is going to be at, I'll say t equals 1.33 weeks. And actually this happens a second time, right? So we need to intersection here. So second calc, one more time, down to intersect. We can also hit 5. First curve is this blue one. Second curve is the red one. Guess, let's get closer to that intersection that we're looking for. Hit enter, and it will grab this one as well. So let's see if I can actually just grab a quick screenshot of this. And that second one is 6.67 weeks. So again, we're kind of looking for where the two graphs intersect. So, and then for 6,000, I'm going to do the same thing. So let's do graph y equals 6,000. Hit graph, and we'll see what we get. And this time it looks like I'm only intersecting once in this interval. Yes is going to intersect more times, but within 0 to 12, it's just that one time. And this is going to be at 9.33. So for number 2, y is going to equal 6,000 when t equals 9.33 weeks. Okay, moving right along. Letter D, during what time interval or intervals does the population size exceed 10,000? So once again, I'm looking, this is a y value, and I'm asked to find a time interval, so I'm looking for t. So again, I'm going to have to graph that y value of 10,000 this time, and I'm going to compare that against my graph and see for what period of time in which weeks is my graph above this line. So I'm actually like interested in this area. So this is actually my interval that I'm interested in. So it's basically from this x value to this x value. So I need to, once again, find those intersections and just describe that as an interval. So let's do that. So second calc, 5.49. And that is my interval there. You'll notice that I used open parentheses, not square brackets, because I'm looking for when it's exceeding 10,000, and at these values it equals 10,000. So it's not actually going to contain these points in my interval. That's why I use the open parentheses. So lots of different problems for this one, or lots of different features and aspects. Really, if we know how to use the calculator and we know how to identify A's, B's, C's, and D's, then we should be just fine. So why don't you try this example here. Pause the video, give this one a shot. I recommend that you graph this thing first so you can pull a lot of information from your graph and use the calculator when you need it. So go ahead and pause the video and resume when you are ready. Okay, and here is your answer for A, B, C, and this is the graph. Hopefully you got everything okay. If you need to, rewatch parts of the video if you're a little confused, and thanks for watching.